Welcome to part 3 of how to factor and not die. In this video, we'll be going over some shortcuts to factoring specific types of trinomials and identifying those patterns. And we're also going to look at the infamous, potentially terrifying completing the square method of solving quadratics. And it's not technically factoring, but it's close enough related to perfect square trinomials that it felt worth it to kind of take a detour and show you how to do that as well. And we will make it less terrifying. So let's get started. Trinomials come in this basic form ax squared plus bx plus c, where a, b, and c are all constants. For example, you could have 2x squared plus 5x plus 3, where 2 is a, 5 is b, and 3 is c. And I'm just telling you this so that you know what I'm talking about because I'm going to be referring to this notation a lot. Most of the time when you're factoring, you'll have to do some somewhat long process to figure out what the factors are, but occasionally the relationship between these three coefficients can tell us pretty quickly exactly what the expression's factors are, which is awesome. So let's learn how to identify some of these. So let's say we have something like x plus 2 times x minus 2, and we do this out using the FOIL method. So we'll get x squared minus 2x plus 2x minus 4. And you'll notice that this 2x and that 2x cancel out, so we're just left with x squared minus 4. And so we call this situation a difference of squares, because we have a square right here, x squared, and then we have another square right here, 4. And it's difference because there's a subtraction sign. So you might notice that we got x squared minus 2 squared from x plus 2 times x minus 2. And this is actually a really common pattern. So if we want to generalize it, really, it's just that x minus a times x plus a is always going to give us a difference of squares. It's going to give us x squared minus a squared. So why do we need to know this? Well, if we see, for example, something like x squared minus 25 and we want to factor it, instead of going through the whole factoring process, we can say, hey, wait a sec. This is a difference of squares, right? Because it's x squared minus 5 squared. So we go back and look at what the pattern should be, and that tells us if 25 is a squared, then a is going to be 5, right? So this really just factors to be x minus 5 times x plus 5. And what maybe could have taken 1-2 minutes for us to factor was instantaneous. And this works for more complex examples as well. For example, we can have a coefficient in front of the x, and as long as the coefficient is a square, it still works. So let's say we have 4x squared minus 16. We can recognize, okay, 4x squared is just 2x squared, right? And then 16 is 4 squared. And we have the subtraction in the middle, so it works out. So what we can factor it into is 2x minus 4 times 2x plus 4. So the only thing you need to watch out for is to make sure that this symbol in the middle is a negative, because it's called a difference of squares for a reason. If you have 4x squared plus 16, that's not going to work. Then you're going to have to do out the factoring pattern because it's going to be something different. So just keep an eye out for that. Next up, we're going to look at squared trinomials. Now, it's a common misconception that if you have something like x plus 3 squared, that's going to get you x squared plus 3 squared, or x squared plus 9. That is wrong. That is so terribly wrong. If you ever want a math teacher to be mad at you, do that. So why is this wrong? Well, let's FOIL it out. Let's use the FOIL method. So if we multiply x plus 3 times x plus 3, we are going to get, first is x squared, outside is 3x, inside is another 3x, and last is 9. So that's just going to end up being x squared plus 6x plus 9. So we do have that x squared, and we do have that 9, but we also have this middle term that a lot of people forget about. And you might notice that this middle term is just 2 times this term times this term. Because when we FOIL, we do outside, right? 3x, and then we do inside 3x. And because we're multiplying this expression by itself, that outside term and that inside term in the first outside, inside last, they're going to be the same thing. So it's going to be 2 times this first term times this second term. Let's look at another example. So let's say we have 2x plus 1 squared, or just 2x plus 1 times 2x plus 1. We FOIL it out, we get 4x squared plus 2x plus 2x plus 1, or 4x squared plus 4x plus 1. Once again, look at the pattern. We have the first term squared, we have the last term squared right here and here, but then we also have this middle term, which is going to be 2 times this term times this term. 2 times 2x times 1 is going to be 4x, right? Please excuse the inconsistencies with my 2's. So let's go ahead and generalize this pattern. Let's say that we have a plus b squared. We know that's always going to give us a squared, that first term squared, plus 2ab, so this term times 2, plus the last term squared, so b squared. And there we go, we have another factoring pattern. So once again, how do we use this? Let's look at an example. So let's say we're doing our math homework and we come across something like x squared plus 4x plus 4. I'm like, oh, okay, I guess I gotta factor this. But then you can look at it and you say, wait, hold on a sec. I have a squared term at the front. I have a squared term at the end. So you can say, okay, if this is a squared and this is b squared, that means for this to be a squared trinomial, this has to be 2ab. So let's check. Well, a is going to be x, b is going to be 2, so 2ab is going to be equal to 4x. And look, that checks out. We have a 4x here. So what can we do? We use this factoring pattern and we recognize that this is just x plus 2 squared. So factoring patterns are all about finding these shortcuts, and they'll get easier to recognize over time, but you'll be happy in the long run when you have these in your arsenal. Before we move on, I'm just going to show you one more example with a coefficient in front of x. So what if we have, let's say, 16x squared plus 24x plus 9. So we can look right away and we say, okay, we have a square here that's the same thing as 4x squared. We have a square here that's the same thing as 3 squared. So do we have that 2ab term? Well, a is 4x, b is 3, and then we multiply it by 2, and we would get 24x. And look at that, we have 24x right here. So what do? We use the factoring pattern. And so we know if 4x is our a, 3 is our b, then a plus b squared is going to be 4x plus 3 squared. And that's our factored trinomial. And it's important to keep in mind that this method works even if a or b is negative. So if we have something like 3x minus 1 squared, that's going to multiply out to be 9x squared minus 6x plus 1. So we have our a squared, we have our b squared, but we have to, when we see that our 2ab is negative like that, we know that either a or b is going to be negative, right? We just don't see it in the final product because our a is squared and our b is squared, so it's always going to be positive. So if you see something like that and you see the negative 2ab, just know that you're going to have, instead of a plus sign, you're going to have a minus sign here. So a squared minus 2ab plus b squared is just going to factor out to be a minus b squared. So that's just good to know, just so you don't miss an opportunity to take an easy way out of factoring. So now I'm going to introduce you to something that's super helpful for solving quadratic equations, and it's called completing the square. So basically, as much as we love factoring, it's not going to be possible for every trinomial. It's just not. I'm sorry. But luckily, we have this super cool thing called completing the square that makes the unfactorable factorable. So let's say that we have something like x squared minus 8x equals y. And just for the easiness of it, let's make y equal to 0 in this case. So if we had like a parabola and we were trying to figure out the zeros of the parabola, that's a case where we would, set y equal to 0 and then solve for the roots of that. So this method is called the completing the square method, because what we want to do is we want to take something like this, like x squared minus 8x, which that's not a perfect square trinomial, right? Because we have the first squared term, but we don't have a last squared term. So we want to take something like that, and we want to turn it into a perfect square trinomial. So how do we do that? Well, we know that a perfect square trinomial is in the form a squared plus 2ab plus b squared, right? So let's say our a is x, right? So we'll say our a is x. Then let's say our 2ab is this negative 8x, right? So if 2ab equals negative 8x and a is x, that means that 2b equals negative 8 and b is equal to negative 4. So then how do we complete the square? Well, the only piece that we're missing is this b squared component, right? So why don't we just add on a b squared component? So let's add our b squared. So we'll have x squared minus 8x. Then let's add b squared, which is going to be negative 4 squared, or 16. And then now that we have an equation, we got to make sure to add whatever we add to one side to both sides, right? So we're also going to add 16 to this side. So 0 plus 16 is 16, right? And now, look at that. We have a perfect square trinomial on this side. So from there, all we got to do, we recognize that it's a perfect square trinomial. And so we factor it, and we know that it's going to be x minus 4 squared, right, is equal to 16. And from here, you would go on to solve the actual equation. So you probably don't need to know how to do this right now, but if you want to know, you can then say, okay, x minus 4 squared is equal to 16. So you can take the square root of both sides. You'll get x minus 4 equals the square root of 16, either positive or negative square root. And then x minus 4 equals negative 4. So x is equal to 0, or x minus 4 equals positive 4, and x is equal to 8. So that's how you use completing the square to solve an actual quadratic equation. Let's look at another example because I know it's confusing, and then we'll generalize it. So let's say we have 4x squared plus 12x minus 1 is equal to 0. So in this one, it's a little bit different because we do have a coefficient in front of this x term. So what we're going to do before we do anything else is we're going to divide everything by this coefficient in front of the x squared term, or an ax squared plus bx plus c. That would be the a term. So divide everything. We're going to have x squared plus 3x minus 1/4 equals 0. And the next thing we're going to do is we're going to move this 1/4 term to the other side. We don't want it here. It's not going to help us out, so we're going to move it over. So we have x squared plus 3x equals 1/4, and we'll deal with that 1/4 later. So now we're going to try to get ourselves a nice perfect square trinomial. So if x squared is our a squared term, we are going to say that a is equal to x. Then we know that 3x is equal to 2ab. So 3x equals 2bx, and b is equal to 3 over 2. So now what we want to do is add the b squared term, right? So we're going to add on b squared, which is the same as 3 over 2 squared, or 9 over 4. And we're going to end up with x squared plus 3x plus 9 over 4 is equal to 1/4 plus 9 over 4, because remember we have to add to both sides. And just a quick shortcut to show you if you're wondering how to do this a little bit easier. You might notice that essentially what we did to find this b squared term was take in the expression ax squared plus bx plus c, this would be our b term, right? I know it's kind of confusing because I used a and b for both. Hopefully you can differentiate between the two. But we take our middle term, or our b term, and we divide it by 2, and then we square the whole thing, right? Because it's ultimately squared at the end. So here we did 3 divided by 2, and then squared the whole thing to get 9/4. So now our final step in the process, we now have a perfect square trinomial, and so we can take this x squared plus 3x plus 9/4 and turn it into x plus 3/2 squared is equal to 10/4. And then if you wanted to solve it from there, you would just take the square root of both sides again, and then from there you can solve for the positive and negative values. All in all, just remember that our ultimate goal with completing the square is trying to make yourself a perfect square on that one side of the equation to make solving the whole quadratic equation just a little bit easier, so you don't have to go through like the messiness of the quadratic formula and everything. Hopefully that was helpful in your learning how to recognize and create patterns to make your factoring life easier. Once again, thank you so much for watching my video. I really appreciate it. And if you want to go back and watch my other videos about factoring, to learn how to factor trinomials or how to do some basic factoring stuff, you should go do that. So yeah, thank you.